All of you say, what is the question here? Draw the typical VI characteristics of a silicon diode. Okay. So you have to do the VI characteristics of a diode. 3-mark question or 2-mark question, graph will come. Only one graph you have to draw. VI characteristics means what? The graph between voltage and current. Okay, for PN junction diode. So first for graph, what you do here? So first you do here one y-axis and x-axis. Okay. So first you do one y-axis. First you do one y-axis here. Now next one x-axis. Yes or no? Now here in y-axis you take. This is your current I. Write in milliampere. Okay. And downward you write I. This is in microampere. This is in microampere. Now here you write. The x-axis you take voltage. Voltage. That is basically V. Forward bias voltage. V you take. And here in x-axis, negative x-axis you take reverse bias voltage. Here voltage basically what voltage? You can write this one as forward bias voltage. These are forward bias voltage. Forward bias voltage. Okay. Write down that forward bias voltage in x-axis, forward bias voltage, and in x-axis, negative x-axis, you take reverse bias voltage, forward bias voltage. Here you write reverse bias voltage. Let me write here reverse bias voltage. Now what you do? Scaling you take, scaling. What scaling? Now first you take here, this is 0.2, this is in volt actually. This one you take 0.4, 0.2. Next write, this one is 0.4. The next one write 0.6. The next one write 0.8. Like this voltage you take. Next 1 volt. 1 volt. 1 volt. 9 milliampere what you take current? 20 milliampere. Then 40 milliampere. Then 60 milliampere. Then 80 milliampere. 100 milliampere. Like this you take current. Now in reverse burst voltage you take higher voltage, 20. So 20 volt, 40 volt, 60 volt, 80 volt. Like this you take up to 100 volt. You can take also 100 volt. Next here reverse saturation, that current, reverse current, microampere current, that one you take like this, 10 ampere, 10 microampere actually, then 20 microampere, then 30 microampere. Okay. See, forward current in milliampere, that's why milliampere given here. Here reverse current in microampere, that's why microampere given. Now draw the diagram. How to draw the diagram? Your reverse bias voltage taken, reverse bias voltage, your forward bias voltage. Okay. Now here for silicon diode, your barrier potential is 0.7. So up to 0.7 current will be 0. Current will be 0. At 0.7 only current will be increasing. Current will be increasing. So that one you can show like this in yellow color graph. Again I am saying, okay, current will be 0 up to 0.6, from 0.7, okay, up to, in the from 0.7 current will be increasing. Now see 0.2 current 0, 0.4 current 0, 0.7 current is increasing. Okay, so this is your forward bias characteristics. What is this one? Forward bias characteristics. Okay, right, this one is your forward bias characteristics. Forward bias characteristic. Next listen. Reverse bias. Reverse bias you check. Current will be saturating. Current will be saturating. Then at V equal to VBR, current will be increasing. V equal to VBR, current will be increasing. Yes or no? So do the graph like that. At V equal to VBR, current will be increasing. Do a graph. Saturation current from 0 up to 20 volt saturation current is same, 60 volt saturation current will be same, between 80 to 100 current will increase vigorously like this. So this is the diagram for what? VI characteristics of silicon diode. VI characteristics of silicon diode. This diagram you need to do. Everyone listen carefully. This current is saturation current. Already you know saturation current. In reverse bias, the current is independent of. Current is mostly independent of what? Current is independent of voltage, applied voltage. So current will saturate. Current will saturate. Okay, like this you draw no worries. Current will saturate. So this region basically, this region is called saturation current region. After that, at V equal to VBR, at V equal to, here I'll write this point basically. What is this point? V equal to VBR, breakdown voltage. Current is increasing sharply. Current is increasing sharply. Yes or no? So this is the diagram for VI characteristics of silicon diode. This diagram you have to draw. Yellow color it is given. Diagram, that graph. Now here you write, this is your reverse bias characteristics. Reverse bias characteristic. And this one is your forward bias characteristics. Okay, so VI characteristics of silicon diode, you remember. Okay, reverse current will be in microampere, forward current will be in milliampere. All these points you have to mention. Okay, VBR, and here one point is there, this is your VB. Here one point is coming VB. So you can write here what is VBR and VB. Okay, in the below graph you can write VBR is breakdown voltage and VB is basically knee voltage. Okay, VB is knee voltage, or VB is called also barrier potential. VB is called barrier potential or knee voltage. So below this graph you can write what is your VBR. VBR is breakdown voltage. Breakdown voltage. And what is your VB? Now VB is knee voltage. Knee voltage. Okay. For silicon diode at 0.7 only current will increase. For germanium diode at 0.3 current will increase sharply in forward bias. Okay. So this diagram alone you have to do. Okay. Remember, forward bias voltage will be in the order of what? 0.2 volt, 0.4 volt like that. Reverse bias voltage will be 20, 40, 60, 80 like that in volt. It's everything in volt. Reverse bias in volt you are taken in volt. Okay, and reverse bias voltage. But a current in milliampere for a forward current, reverse current in microampere. Okay, this diagram you have to do, everyone. Okay, suppose this number value you don't remember or you can't remember, normal graph you do, no worries. Okay, mark will be given, but thing is if you do it is better little. Okay, because typically silicon diode were asking for silicon diode at 0.7 it should go barrier potential, it should increase the current. So that one also you should mention, right? Like that type of things you should do it. So this is the idea about VA characteristics of silicon diode. Clear? Graph is clear? No doubt? Okay. So note it down. Note it down all of you. Thank you.